Welcome back to the deep dive. If you joined us last time, you know we're kind of digging into this fast-moving world of AI.
That's right.
Today, it's part two of our look at how we actually interact with these systems. We're tackling large language models, LLMs, and this thing called LLMOps that's cropping up.
Yeah, exactly. And we've got a whole bunch of interesting stuff to unpack. It's like lifting the hood on these, text-generating machines.
Hmm.
We're looking at everything from, like, basic definitions in an LLM dictionary to insights from people like IBM and Andre H. Karpathy on how they're actually built.
Okay.
Plus articles on the tech behind text generation, transformer networks, even a Reddit thread about how using LLMs feels almost like, well, magic sometimes.
Ah, yeah, I can see that.
And practical guides, too, on writing prompts, plus some overviews and stuff on training and managing these models.
Okay, great. So our goal today is really to get a clear picture of what LLMs are, why they're such a big deal right now, how we use prompts to sort of steer them, and why this LLM field is becoming so critical.
Sounds good.
So let's just jump in. What is a large language model, fundamentally?
Okay, imagine an AI that's basically read a huge chunk of the internet,
Hmm.
plus, tons of books, articles, all sorts of text.
Right.
A large language model, or LLM, is essentially that. It's a really sophisticated AI trained on just massive amounts of text data.
Okay.
And its main skill is understanding and then
Yeah.
generating text that sounds, well, remarkably human. It's like a master of language patterns, if that makes sense.
Okay, so it's not just like spitting back what it read. What makes them so useful? What can you actually uh, do with one?
Oh, they're incredibly versatile. You've probably run into them already, even if you didn't realize it.
Yeah.
They can answer questions pretty coherently, have conversations, summarize, long articles into bullet points, even translate languages.
Mm.
That chat bot that pops up on a website, good chance there's an LLM behind it. It's not
Mhm.
just about information access. It's like having an assistant that can process and synthesize information like a person would.
That's a really good way to think about it, an intelligent assistant. Now, you mentioned, or the materials mentioned, something called a transformer model. That's key to how a lot of these work.
Yeah, that's right. The transformer model is kind of the engine under the hood for many of the most powerful LLMs today. Think of it as a newer, smarter way for AI to handle language.
How so? Different from older ways.
Definitely. Older methods tended to look at text sequentially, like word by word in order.
Yeah.
The transformer, though, it can look at all the words in a sentence or even a longer piece at the same time. It uses something called self-attention mechanisms.
Self-attention, what's that?
It's a bit technical, but imagine the model figuring out which words in a sentence are most important to understanding the meaning of any other word. It weighs the connections between words, no matter how far apart they are.
Ah, so it gets the context better.
Exactly. It understands the relationships between words across the whole input, not just the ones right next to each other. That ability to grasp context over longer stretches is, well, it's a huge step up.
So it's like the model can see the whole picture at once, kind of, instead of just word, word, word. That must make a huge difference.
Absolutely. It helps them learn those really complex patterns in language much faster and, frankly, much more effectively than the older methods could.
Okay, wow. Now, building one of these massive models, that sounds like a serious project. Can you walk us through the basic steps? What goes into creating an LLM?
It is, yeah. It's a significant undertaking. The first big phase is all about the data, like
Oh.
preparing this gigantic library for the model to learn from.
Right.
This means doing things like categorizing the text. Is it English? Is it code? Is it news? Stuff like that. Then there's a really crucial cleaning and filtering step.
Filtering. What are you filtering out?
Things you don't want the model learning, ideally,
Hmm.
like hate speech, profanity, maybe copyrighted material it shouldn't reproduce, or even just duplicate sentences that don't add value.
Makes sense.
The aim is to get this high-quality, clean data set. Sometimes it's called a base data pile. And interestingly, like you mentioned with good hygiene, this data pile can actually be versioned.
Ah, versioning the data. That's smart. So you know exactly what went into a specific model version.
Precisely. It's key for tracking what the model learned from and for reproducibility.
Okay, so you've got this pristine version data set. What's next?
Then comes the actual training. You choose a foundational model architecture. There are different types.
Yeah.
Some are better for generation, some for understanding, some are smaller, some are huge.
Right.
Then you take that clean data and break it down into smaller units called tokens. These aren't always whole words. Sometimes they're parts of words.
Tokens. Okay.
This huge amount of tokenized data is then fed into the model architecture.
Hmm.
And the training itself, well, it takes serious computing power. We're talking potentially weeks or even months on massive clusters of GPUs.
Weeks or months just
Yeah,
processing data. The scale is kind of mind-boggling.
it really is.
So after all that time and computation, what happens? Is it just done?
Not quite. After the main training, the model needs to be evaluated. You run it through standardized tests called benchmarks to see how well it performs on different tasks.
Like grading its homework?
Sort of, yeah.
Yeah.
And often, a model card is created. Think of it like a spec sheet or a report card for the model outlining its capabilities, its limitations, how it did on those benchmarks.
Okay, that makes sense. Documenting what it can and can't do. So we have this powerful, trained, evaluated model. How do we as users interact with it? Tell it what to do. That's prompting, right?
Exactly right. Prompting is the term for how we communicate with these LLMs.
Yeah.
It's basically the text input we give the model to guide it toward the output we want.
So like giving instructions.
Yeah, or a starting point or a question. And the thing is, the quality of your prompt makes a massive difference. A well-crafted prompt gets you much better, more relevant results.
Ah, okay.
And that's where this whole skill of prompt engineering comes in. It's about learning how to write effective prompts.
So it's not just typing a question. There's an art or a science to it. How does the model actually decide what words to generate after we give it that prompt?
Well, it generates the response token by token.
All
Remember?
right, the little word pieces.
Yeah. So to decide the next token, it looks at all the possible tokens it knows and calculates the probability for each one. Which token is most likely to come next, given the prompt and the tokens it's already generated?
Okay, so it's all probabilities.
Pretty much. And there are different strategies for picking that next token. Sometimes it just picks the single most probable one, that's called greedy sampling. Other times it might consider a few top options, or even add a bit of randomness based on the probabilities to make the output less predictable, maybe more creative.
Interesting. So you can tune how predictable or creative it is based on how it picks the next token.
Exactly. There's often a balancing act there. And underpinning all this are the model's parameters.
Parameters, right. I hear that term a lot. What are they really?
You can think of them as the connections, the weights, the sort of internal knowledge the model learned during training. There can be billions or even trillions of these parameters in the really big models.
Trillions.
Yeah. That sheer number is why we call them large language models, and it's a big part of what gives them their impressive capabilities.
And all that knowledge, those trillions of parameters, that comes from that massive pre-training phase you described earlier.
Mostly, yes.
Yeah.
That pre-training on just enormous amounts of text gives the LLM a really broad understanding of language grammar, facts, reasoning patterns, even some common sense.
Okay.
And then that general foundation can often be adapted or fine-tuned for more specific jobs by training it a bit more on smaller task-focused data sets.
Right. Fine-tuning for specific tasks. Got it.
Okay.
That gives us a really solid foundation on LLMs. Let's shift gears a bit to this other term, LLMOPs. What's the story there? Why is this becoming a thing?
Well, think back to software development before DevOps really took hold.
Yeah.
You often had the developers building the code.
Right, throwing it over the wall.
Exactly. Throwing it over the wall to the operations team, who had to figure out how to run it and keep it stable. DevOps aimed to break down that wall, streamline the whole process.
Yeah, integrate development and operations.
The LLMOps is doing something very similar, but specifically for large language models. It's about managing the entire lifecycle of an LLM, especially when you move it out of the research phase and into actual, production applications.
So it's the practical side of using these things, making sure they work reliably in the real world.
That's a big part of it, yeah.
Yeah.
Getting LLMs running reliably and effectively in production is, well, it's tricky. There are unique challenges.
Huh?
LLMOps provides a set of practices, tools, a framework, really, for building, deploying, monitoring, and continuously improving these LLM-based systems.
Okay.
It definitely builds on DevOps principles, but it's tailored for the specifics of AI and machine learning, particularly these big language models.
That clicks for me, thinking about my DevOps background. You need that operational rigor. So what are the key pieces? What makes up LLMOps?
There are several core components. First off, data management is huge. You need robust processes for handling the data used for training, for fine-tuning, for evaluation, ensuring quality, tracking lineage. It ties right back to that base data pile prep we talked about.
Right, data is fundamental. What else?
Then there's model training and tuning. This isn't just the initial big training run. It's also about efficiently fine-tuning models for specific tasks, maybe using techniques to do that without retraining the whole thing and managing those training processes.
Okay, data and training makes sense. What about once the model exists?
Yeah, versioning is absolutely essential. You need to track different versions of the models and the data they were trained on and maybe the code used. This is crucial for reproducibility, for audits, for rolling back if a new version has
Like
problems.
version control for models?
Kind of,
Yeah.
yeah, but often more complex. Then there's monitoring. Once a model is deployed, you have to watch it. Is it performing well? Is it giving weird answers? Is its accuracy drifting? You need systems to track that constantly.
Active monitoring, not just deploy and forget.
Definitely not. And finally, deployment. How do you actually get the model out there so applications can use it? Is it an API in the cloud? Is it embedded on a device? Managing that deployment process is key.
Wow. Okay, so it really is a whole life cycle thing. Data, training, versioning, monitoring, deployment. It's a continuous loop.
It absolutely is.
Yep.
And you see platforms emerging to help with this, like IBM's Watson X aims to provide tools across that lifecycle data management, governance, AI model building. NVIDIA's Run.ai platform helps manage the heavy-duty computing resources you need for all this.
So the industry is building tools specifically for these LLMOps challenges.
For sure. The rise of LLMs really shows that people recognize managing these powerful AI models in production needs its own dedicated discipline, its own best practices to ensure they're reliable, scalable, and governed properly.
It sounds absolutely critical for any company serious about using LLMs in their products or operations.
I'd say so. It's about bringing that engineering discipline to AI to make it practical and trustworthy at scale.
This has been super helpful in understanding LLMOps. Now, connecting it all back, we have these increasingly powerful LLMs. We have this emerging discipline of LLMOps to manage them. What does all this mean for prompt engineering? Is that still important?
Oh, absolutely. I'd argue it becomes even more important as the models get more capable. Our ability to communicate our intentions clearly through prompts is, well, it's paramount. That's still the primary way we steer these things.
So better AI doesn't mean we don't need to be good at asking.
Not at all. In fact, the potential impact of a well-crafted prompt versus a poor one probably grows as the model's capabilities expand. Prompt engineers, the people who specialize in this, they're likely going to be really valuable members of LLMOps teams, of AI project teams in general.
Huh. So it's a skill set that sits alongside the more operational stuff.
Definitely. Their expertise in getting the best possible performance out of an LLM for a specific task. That's crucial for building successful applications. Understanding different techniques like giving the model examples in the prompt or structuring prompts carefully for, say, sentiment analysis, that becomes even more valuable knowledge.
We're already seeing some advanced prompting techniques pop up, right?
Yeah, absolutely. Things are evolving fast. We see stuff like chain of thought prompting where you guide the model to sort of think out loud step by step. That can really improve performance on complex reasoning tasks, especially with the bigger models.
Right.
Or even the idea of negative prompts, especially in image generation where you tell the AI what you don't want to see. It shows how nuanced prompting is becoming.
Negative prompts. Yeah, that's fascinating. Specifying the don'ts.
Exactly.
Mm.
And as these models maybe get the ability to use external tools or databases or have more agency to act, prompting might evolve again. Maybe it becomes more about orchestrating complex tasks, guiding AI agents towards bigger goals.
So the role of the prompt engineer could actually expand quite a bit.
I think it's very likely. It remains this critical interface between human intent and the model's capabilities. And even understanding how models work internally, this field called mechanistic interpretability, that could eventually feed back into how we design better prompts too.
Wow. So prompt engineering seems like it has a really dynamic future, tightly linked with how LLMs and LLMOps evolve.
Absolutely. It's right there at the intersection.
Well, this has been a fantastic deep dive. As we start to wrap up, hopefully you listening now have a much clearer sense of large language models, what they are, why they're making such waves.
Yeah, and also this crucial operational side, LLMOps, needed to manage them effectively in the real world.
And why prompt engineering isn't just a temporary trick, but a really important and evolving skill for interacting with these powerful AIs.
We've touched on how they learn from vast data, use complex architectures like transformers, generate text based on probabilities,
Yeah.
and the whole lifecycle management piece.
Right. The future of how we communicate and collaborate with AI through language is just incredibly exciting. And understanding these core ideas, LLMs, LLMOps, prompting, that's going to be so valuable as things keep moving.
Definitely. And maybe something to think about is, as these models get even more woven into our lives, How will we need to adapt how we talk to them? What new skills or even ethical considerations pop up as these powerful tools become more common?
That's a great question to leave people with. Definitely more to explore there. Thanks for tuning into this deep dive.